So this one is to use when you have many sequence. So you will need to determine which sequence to be used. This example, it shows you a composition of 4-component mixture. K values for each component at the bubble point temperature is given. So the liquid and vapor phase mixture of these components may be assumed to behave ideally. Okay. A distillation sequence is proposed for the separation process. The minimum reflux ratio for each column in this sequence is given. Okay, so your lucky Armin is given. No need to calculate already. Okay, for this question. Now, the feed and all distillation products may be assumed to be liquids at their bubble point temperature. It asks you to calculate total vapor load. So V total, not V min, V total. The vapor flow produced in all reboilers in the sequence. So assuming actual to minimum reflux ratio of 1.2 to 1. Actual to minimum reflux ratio. Armin is given. Okay, so actual R is 1.2. Huh? Okay. Right. Actual is 1.2 multiplied by Armin. Okay, this one from this, from this statement. This is not fixed. This is from this statement. Okay, moving forward. First step, we need to calculate the distillate flow for each column. Distillate flow for each column. We have 3 columns over here. Okay, 3 columns. 1, 2, 3. Okay, for column 1, the distillate, this is the distillate A, B. Okay, distillate for column 1 is A plus B. Distillate for column 2 is, wait, let me label. What is AB? A is AB. A, B, B, B. Okay. A. Okay. Here is C plus D. Now, column 1, calculate the distillate only. Distillate. Why distillate only, not bottom? Vapor. Because we want to calculate the vapor, total vapor. Okay. Now, distillate, column 1, A plus B. 0.05 here is the mole fraction in the feed over here. This one. You can check your slide back. Okay. Multiply by 150. Where does 150 come from? Here. total flow rate. Okay. Now plus B, mole fraction of B is 0.3. Here. Multiply by 150. Now this is distillate for column 1. D1. For column 2, which is only A. Okay, 0.05 multiplied by 150. So you'll get 7.5. So D2. Column 3, which is only the C. Okay, C here, 0.45 multiplied by 150. So this is D3. This is only the distillate, not yet the vapor load. Next step, once you get the distillate for each column, next is to calculate the vapor flow. Vapor flow for each column. So to calculate the vapor flow, this equation. Vapor flow. We are not looking for Vmin. This is vapor flow. Why we calculate vapor flow, not Vmin? Why do you calculate the V, not Vmin? Here you calculate using this equation. Because what? Because the question asks you to calculate the total vapor load. It doesn't mention vapor min, right? Okay, so it asks you to calculate the vapor load, total vapor load, not the V min. Okay, understand the question before you start answering. Total vapor load. So this equation. If the question asks you to calculate total V min, then only you use the V min over here. Yes. Okay, always refer back to the question. This question asks you to calculate total vapor load. So that's why we use this equation. Okay, so V1 for column 1, which using the D1 just now. Okay, so this is the D1. The D1 for column 1 multiplied by 1 plus RF R min. So just now it already mentioned 1.2 multiplied by R min. Where this figure comes from? Given. Okay, it's given here. Column 1, use R min for column 1. The what? RF. The ratio. What? Okay, so here RF equals to 1.2 is based on the statement from the question. Okay, 1.2. Now, next, calculate V2 for column 2. This is the D2 that we calculate earlier. R min for column 2. Okay, R min for column 2. Okay, so you will get V2. Next, V3. This is the D3 that you calculated earlier. This one. Using R min for column 3. So you will get this. Okay, so this is not your final answer yet. Once you get vapor flow for each column, sum them all to find the V total. Okay, so the V total, V1 plus V2 plus V3. Okay. Any question? Nothing. Perhaps we will discuss tomorrow. Okay. Now this another example. This sequence, okay, this one there are two sequence. Sequence 1 and sequence 2. The question asks you to decide which sequence is better for further evaluation. Okay, so you have two sequences over here. You need to determine which sequence to proceed. Okay, how? By looking at the V min for each sequence. In this example, V min is given. Okay, if V min is not given, then you need to calculate. Now, V min for sequence 1. V1 min, okay, plus V2 min for column 2. Total 15.3. Compare with sequence 2, where you have total of V min is 16.2. So, the lower the better. Choose sequence 1 to proceed. Okay, so sequence 1 is chosen to proceed because it has a lower total vapor flow compared to sequence 2. Okay. Now, once you determine sequence 1 is having lower total vapor flow, then you will need to determine the costing. Okay, to estimate the cost, these are the few things to follow. Okay, first is to set appropriate distillate bottoms and column pressure. The higher the pressure, the higher the cost. Right? So that's why we will go to the lowest vapor flow. Okay, steps 2. Estimate number of stages and reflux ratio by WUG method. This one is the Underwood method. Okay, step 3. Select trace spacing. Typically 2 feet. This one you have done in PED, right? So those things lah. Then compute tower diameter Then estimate the install cost of tower. Calculate the size and cost of the equipment. Okay. Then compute the annual cost of the utilities. Then you should calculate the CA, annual cost, assuming the ROI. Okay, this part you have done in detail in your PED, right? Okay. Now this example, it shows you to estimate the annual cost. Using the example, using the previous example, this one, previous example, we have product A, B, C, D, E, F, where you will need to recover A, B, C, F, okay, propane and butanes, and N-pentanes. These are the one that you will recover. From those feed, you will have many sequences. Huh? No need. This one for your understanding. I will not ask this kind of question. Huh? This one is for your understanding into determining which sequence is the best. Just now we calculate the vapor flow to determine the best sequence. Lower vapor flow is the better. Now when it involves the cost, we will compare cost for each sequence. Okay, from the feed that we have, there are many sequences that can be generated. Okay, for example, here sequence, this sequence, okay, the green highlighted sequence, it costs 872. For the second branch, this sequence has the lowest. Okay, you will need to compare for each branch. For second branch, this sequence is the lowest, where it only get 860. Okay, move to third branch. This sequence is the best, that has the lowest. Next branch, this sequence cost this much of amount. Okay, 1 million something. So from all these costing analysis, compile them, then you will see second sequence that is having the lowest cost. Second sequence is this. Okay, so this is the second sequence that has the lowest cost. So from this analysis, you can proceed further for the plant design. Okay, so from this sequence, then you can proceed further for the rest. Once you decide the best sequence based on the vapor flow, based on the cost, proceed with the overall process, then you can install your control device, instrumentation, everything. Okay. The what? Correct. Yes. This part is the BFD only. BFD. BFD. Sorry. The BFD. PFD of the most feasible sequence. Okay, whereby this one is the PFD, where you can see all those equipments. Okay, this is PFD. Huh? Huh? No, the costing no. Okay, so the midterm will not cover on the costing part here. Okay, this is for your own understanding. Okay, so we are done with chapter 3. Any question? Tomorrow we will do exercise from previous perhaps midterm or final exam question. Okay? Okay, that's all class. Thank you. I forgot to distribute the attendance. So today all attend.